So in 7.3 part 2, we are going to talk about the unit circle some more, how we use it, how we build it, and hopefully this will help you memorize it completely. That's the goal. So build it with me again when we get to that point. But first I want to talk about something called a reference angle. First I want to talk about something called a reference angle. The reference angle is how far away we are from the x-axis. It is the angular distance we are away from the x-axis. Okay. Now, the reason it's important to think about the reference angle is when we were talking about building that unit circle, remember I had made like all of the ones that had a reference of 30 in red and all the ones that had a reference of 45 in green. The reason I do that is because they're all going to be related. They're radians. Like our 30-degree references all had a 6 denominator. They all use the same point on the unit circle, so that reference angle is really important. So I want to talk about how we draw those. So let's talk about the first one here. Let's say we have a theta of 45. We would draw that like that. In this particular case, how far away are we from the x-axis happens to be theta. So theta and theta prime are the same. We are 45 degrees away from the x-axis. Our theta and our reference angle theta prime are the same darn thing. So that's what this says here, that if you are in the first quadrant, your theta and theta prime match. So that theta prime is going to be our reference angle. So our theta prime is going to be our reference angle. So now let's look at where 120 would sit. 120 lands us about right here. Now, we're just... Yeah. Thanks. So here's 120. That's what 120 looks like, okay? But the reference angle actually, so this is theta. Theta prime actually is the distance here. So the way that we would calculate theta prime is just we are almost hitting the 180 mark. If you minus 120, you get 60 degrees. And that's what this says down here. If you land in the second quadrant, it's just 180 minus the angle measure that you rotated to, okay? So that's that one. Now let's talk about 7 pi over 6. 7 pi over 6, 6 goes into 180 30 times. So a pi over 6, this pi over 6 alone stands for 30. 7 of them is 210. So when I'm doing this, I usually convert it in my brain or on paper. I like to think of that as 210. Okay. So first, let's draw the approximate location of where 210 takes us. It lands us shoop about right there. Okay, so that's 210. But let's talk about theta prime. Where is the reference angle there? Well, the reference angle is this distance away from the x-axis. So it's how much we have passed 180 by. So in this case, theta prime is going to be your theta minus 180, or in this case, 210 minus 180, or 30 degrees. Now, what's great about radians is the pi over 6, the 6 denominator automatically tells me that I have a reference of 30. If it has, when reduced, if it has a denominator of 6, the reference is 30. If it has a denominator of 4, the reference is 45. If it has a denominator of 3, the reference is 60. Remember, they all went together. And then finally, we have our last one here, 5 pi over 3. So 3 goes into 180 60 times. 5 of those is 300. So let's draw where that takes us. 300 is about right here. So if we start at 0 and go around, that's 300. And so how far away are we from touching the x-axis in the quadrant where we land? Well, that would be right here. So to find that, this time we reference 360 degrees. So it's just 360 minus 300. And that's 60 degrees. Now, you don't have to really memorize all these rules at the bottom. They're helpful, but you just always have to say, if I land in that quadrant, how far away am I from hitting the x-axis? That's all you want to think about. That is what a reference angle is. And those reference angles become so important because if we know the unit circle reference angle, then we can find the sine, the cosine, the tangent, and all the other trig functions that match that particular location. Okay, so that is what a reference angle is. And as I was building the triangle, or I'm sorry, building the unit circle, and I showed you those triangles, you probably got a sense about the fact that all of those things go together. Now, for radians, for 180, you would use pi. For 360, you would use 2 pi. Again, feel free to convert to degrees, do all your math, and then you can even come back to radians if you wanted to at the very end, okay? So like this answer would be pi over 6. This answer would be pi over 3 if we went back into radian mode. But I'm okay with you converting back and forth. Remember, a pi over 6 is 30, a pi over 4 is 45, a pi over 3 is 60, and those will really serve you well as you go through this process. So let's just practice doing a few. It says to sketch the angle and then find its reference angle. So let's do the first one. It says negative 150. So here's the negative direction. Here is negative 90. Here is negative 180. So negative 150 is somewhere between negative 90 and negative 180. So I would say it's about right there. Okay, so that is negative 150. Now remember, our reference angle is how far away are we from hitting the x-axis. So our theta prime goes right there. So if we went down 150, how far are we from hitting that 180 spot? 30 more. So our reference angle will always be a positive number between 0 and 180. In this case, it would be 30. So theta prime, it is 30 degrees away from hitting the x-axis. Let's draw B. Pi over 4 is 45 degrees. This is 2 pi over 4, which is really essentially 90 degrees, or pi over 2. This is 3 pi over 4. 3 45-degree wedges. Now you could also take that and make it 3 times 45. and 3 times 45 is 135 degrees. So feel free at any times to change that into radian measure. Degree measure. So our theta prime goes right here. It would take us another 45-degree wedge to get to the 180 mark. So our theta prime, our reference angle, is pi over 4. What's great about radians, if the denominator is pi over 4, the reference angle, or if the denominator is 4, the reference angle will always be pi over 4. If the denominator is 3, it's always going to be pi over 3, or whatever. Okay. And then you could also have called this, I am 45 degrees away from hitting 180. So I don't care if you use degrees or if you use radians, unless they specify in the instructions. Let's take a look at our last one here, 520. If I go one loop around, I get to 360. One rotation is 360 degrees. I hope you know that. So 520, if I subtract off 360, I have 160 more degrees to go. So remember, this is 90, this is 180. I have 160 degrees left to go. So I'm going to land about right there, okay? So that's going 520. It's really going a loop of 360 plus 160 more. So 160 is our key. This theta prime is how much left to get to the 180 mark. So it's just 180 minus 160. And then logically, it tells us that our theta prime is 20 degrees. It takes me 20 more degrees for me to hit the x-axis. So references are always to the x-axis. That's why we put our theta where we put it when we built the triangle, because our theta prime is always in reference to the origin and the x-axis. So when we build a triangle, we always build it in that exact location. Everybody good with how we draw a reference angle and what it kind of looks like and what it is, and does that kind of make sense a little bit? Okay. So how far away are you from the x-axis? Okay. Last week, we talked a little bit about quadrantal angles. We talked a little bit about if we land at 0, 90, 180, or 270, at those locations, there's some magic that happens. Now, we've already done the I'm just seeing what you got there. We already have done some of this stuff. So I'm not going to say too much more about this, except on the little circle that you have right here. Okay. Let's pretend for a moment that this is a unit circle, and we are only going to talk about the quadrantal angles. So this is 0 degrees. We are 1 out and nothing up. Okay. So what you know then is that the sine of 0 is the y value, and the cosine of 0 is the x value. So you know that the sine and the cosine are that way. Remember, the x is our cosine, the y is our sine. Okay. So at 90 degrees, or pi over 2, on the unit circle, the radius is 1, so that lands us at the point 0, 1. So the cosine of 90 degrees is 0, but the sine of 90 degrees is 1. Because remember, this is the x and this is the y. And then over here, this is 180, or pi worth of radians. And that is the point -1, 0. So the cosine of 180 is -1. The sine of 180 is 0. Remember, the cosine is your x and the sine is your y. Remember, xy goes alphabetical. If you go alphabetical, cosine, sine, that might be a way for you to memorize that the x goes with the cosine and the y goes with the sine. And then finally down here, this is 270. That is the point 0, -1. So the cosine of 270 is 0, but the sine of 270 is -1. So remember, your x is your cosine at that location. The sine is the y. The quadrantals are the only ones we can't really build a triangle. So if you just memorize the point that you hit the unit circle, and if you know that the x is the cosine and the y is your sine, you got everything you need as far as the quadrantal angles go. So the quadrantals are either 0, 1, or -1. Be careful when you go to make a tangent. If the cosines are 0, so at these two locations, the y over x, or our tangent, will be undefined. So here we have a tangent that's undefined. Here we have a tangent that's undefined. Here we have tangents that are 0. These tangents work. These tangents do not. If you end up flipping and you have 0 in your denominator, it's undefined. So if you end up with something like 1 over 0, it's undefined. If you end up with 0 over 1, it's just 0. So if 0 is in our numerator, it's okay. It works for the tangent or the cotangent. If 0 goes in our denominator, that's the only ones that don't work. So be careful when you're flipping that, if you're making that y over x for a tangent, because remember, tangent is y over x. So that's all you really need to know about the quadrantals, okay? So that's your quadrantals. So if it says to find the exact value of the quadrantal angle trig functions, what do? So let's look at 2a. Find pi. Pi is just, remember, 180 degrees. The point there is -1, 0. Remember, our cosine is the x value. So the cosine of 180, or pi, is just the x value at the location. The answer is -1. That's how easy and important and wonderful the unit circle is. If they ask for the cosine, it's just the x value at that location. What is 450 in example B? If something is more than 360, find out how much more. Take off the 360 until it's something between 0 and 360, and that would be 90 degrees. So they're really asking me, what is the tangent of 90 degrees? That's what they want. Well, the point at 90 degrees is the point 0, 1. The tangent is y over x at that location. That's something you have to have memorized, that the tangent is y over x at that location. So the y value is 1 and the x value is 0. Let me do that again so I don't take all that with me. When you get 0 denominators, you can write the word undefined, or you can write the null set for me. I'm okay with that. There are no values that make that work. Only if you get 0 denominator. If you get 0 in the numerator, you're okay. If you get 0 in the denominator, that's bad. Let's look at C. Does anybody remember which one of our reference angles has a 2 denominator? what's pi over 2? Anybody remember what pi over 2 is? Every pi is 180 degrees, so what's pi over 2? 90 degrees, half a pi, right? So this is really 790. So we're going to just do a little trick here, okay? So we know pi over 2 is 90. Let's count 7 of them. 1, pi over 2, 2, 3, 4, 5, 6, 7 lands me down there. So all you got to do to find the trig functions at a unit circle value is, where the heck did I land? I landed at 270, or 3 pi over 2. The point at that location is 0, -1. So the tangent is y over x. So that means the cotangent is x over y. The tangent is y over x. So that tells me that the cotangent is x over y. So the x value at that location is 0. The y value at that location is -1. 0 on the top of a fraction is perfectly good. It's just the number 0. So it's the tangent would be undefined, but the cotangent is 0. Okay. So quadrantal angles are great. They're nice. They're either going to give you answers of 0, 1, -1, or undefined. Quadrantal angles are always going to either be 0, 1, -1, or undefined every time. Okay. Okay. So we talked a little bit about this last lesson. So there shouldn't be anything magical or new right there for you. The only thing you really have to write down, I believe, is please just add this in, that the x is your cosine, the y is your sine, and that the tangent is y over x. Please add that, write that down for me. The x is your cosine, the y is your sine, the tangent is y over x. And then I believe everything else is written for you. Okay. And then I believe we're going to build a circle. We're going to do it one more time. Now you are going to have a memory quiz. If you watch that video again from Friday's class, it has everything on it that you need to have memorized. But we do have to have our unit circle memorized completely, every part of it, from the radians, the degrees, and the points. Okay, so now it's time to build the unit circle. Now, you have the circle kind of, it's already kind of color coded for you. So let's start with our quadrantal angles, which are colored in yellow. Okay, so let's start with our quadrantal angles. Let's build them one more time. So this is 0 degrees, 0 radians, 360 degrees, and 2 pi radians. Okay, that is the point 0, 1. Let's go up to 90 degrees. 90 degrees is pi over 2. That is the point, I'm sorry, I saw you guys look at me a little funny. How about this is the point 10? Because we go 1 over and nothing up. This is the point 01. Sorry if I confused you there for a minute. Then we're going to go over here to 180 degrees, which is a pi worth of radians. That is the point -10. Down here is 270 degrees, or we have 3 halves. Now let's talk about how we get that. 90 goes into 270 3 times. We have 1 90 degrees, 2 90 degrees, 3 90 degrees. So we have 3 pi over 2s. We have 3 times 90 is 270. And that there is the point 0, -1. Now, write yourself a little note that xy is cosine sine, and that the tangent is y over x, or sine over cosine. Okay, you do have to know all that. So the quadrantal angles, I believe, are probably one of the easiest. You just have to think, if I hit the circle, the radius 1, I've went 1 over and nothing up at 0, but at 90, I've gone 0 and 1. And then these are the flips of one, you know, the negative version, and then these are the negative version of one another. So that's the way you kind of check your work. Okay, so let's go now. I'm going to do red next. I usually start with the ones that have a 30-degree reference. So let's do those ones next. This is 30 degrees, or pi over 6. Now, the way to remember that is 30 goes into 180 6 times. Remember, it's always degrees, tack on a pi, put it over 180, and reduce if you forget what the radians are. See the 180 in the denominator? That's why I always ask myself, how many times would it go into 180? Let's do over here. I am 180 from hitting this. You don't have to memorize that. Just take off, I'm sorry, I'm 30 degrees from hitting 180. I don't have to memorize that. Just take off 30. What is 180 minus 30? 150. This is 150. How many times does 30 go into 150? 5. That's why we have 5 pi over 6s. Now you could put 150 pi over 180 and reduce, but you're going to get 5 pi over 6. Here I've gone 180 plus 30. So just add on 30. That's why we get 210. 30 goes into 210 7 times. That's why it's 7 pi over 6. And then finally, in the fourth quadrant, I am 30 away from hitting the 360 mark, so I'm at 330. 30 goes into 330 11 times. That's 11 pi over 6. Let's do the points. Look at the triangle that's created if I hit 30. This side is much longer than this side. And this side, you see how it's half of this line? So that's a way to remember that the triangle hits at square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. Now remember, in the first quadrant, we're positive, positive. Quadrant 2, we're negative, positive. Quadrant 3, we're negative, negative. Quadrant 4, we're positive, negative. So that's the way, you know, you can kind of help. It's just XY axis like you've always done it. So let's take our square root of 3 over 2, 1/2. Let's write it down 3 more times, changing the sign in the appropriate way so it lands in that quadrant. So this is the point, negative square root of 3 over 2, positive 1/2. Negative square root of 3 over 2, negative 1/2. Positive square root of 3 over 2, negative 1/2. So the values don't change for anything that has a reference of 30. The only thing that changes are the x and the y. The signs on the x and the y. Okay, now let's go green. We're going to do the 45s. This is 45 degrees. That's pi over 4. How do you remember that? 45 goes into 180 4 times. You can also say, if I cut 90 in half, I would have to double the denominator. A fourth and a fourth make a half. I don't know how you want to remember that, but 45 is the weirdest one to get that first initial spot. So this one right here, if you count the 45-degree wedges, 1, 2, we have 3 of those. This is 3 pi over 4. 45 away from hitting 180 is 135. Those should always be 15 away. Those should always be 15 away. So that's another way you can check your work. They should always be 15 away. It goes 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30. as you go around the circle. Anyway, so 3 pi over 4 is 135 degrees. Here we've gone past 180 by 45, so this is 225. You can add 15 on to here. 210 plus 15 is 225. That ends up being 5 pi over 4 wedges. And you can count 1, 2, 3, 4, 5 45s get me to that spot. And then lastly, in our fourth quadrant, this is 315, which is 7 pi over 4. The pi over 4 numerators count by the odds 1, 3, 5, and 7. That helps you too. The point, because we make an isosceles 45-45 right triangle, are the same. The x and y are both square root of 2 over 2. So they're both square root of 2 over 2. Now let's go ahead and put that square root of 2 over 2 in the locations, changing the sign where appropriately. So this one would be negative square root of 2 over 2 and positive. Negative, negative. And positive, negative. So all the 45 references have square root of 2 over 2s. So I'll let you get caught up on them. And then we're going to do the blue 60s. And then we'll do the blue 60s. Okay, so this one right here is 60 degrees. If you take the 30-degree triangle, and if you flip it on its head, you get the 60-degree triangle. So instead of 1/2, or instead of square root of 3 over 2, 1/2, it would be 1/2 square root of 3 over 2. Now let's talk about the radians. 60 goes into 183 times, so that's why it's pi over 3. And this is 120, which is 2 pi over 3. Same point, but the x is negative. Negative 1/2 square root of 3 over 2. So that's the two top. That's the two top 60s, 60 and 120. Think about it. We have 60 and 60 and 60. 3 60s get to the pi spot, so pi over 3 makes sense, hopefully. Let's do it again down here. 60 past 180, just take 180, add on 60, that's 240. It should be 15, these should all be 15 apart. Add 15, get 225, add 15, get 240. How many pi over 3s is that? Well, 60 goes into 244 times, so this is 4 pi over 3. We're going to use that same 1/2 square root of 3 over 2, except they're both negative in this quadrant, so that's going to be negative 1/2, negative square root of 3 over 2. And then down here, this is going to be 300. 60 goes into 305 times. This is 5 pi over 3. Same point, except this time the x is positive and the y is negative. Now the sign relates to the y value. So the sign is positive for any point that's up here. Any location that's down here, your sign will always be negative. The cosine corresponds with your x's. If you're over here, your cosine will be positive, but if you're over here, your cosine will be negative. Now, tangent is the sine over the cosine, or the y over the x. So since they're both positive, the tangent will be positive here, and two negatives make a positive, so be positive here. So the tangents are positive there and there. The tangents are negative here and here because one of the x's is positive and one of the y's is negative, or vice versa. So tangent is positive here and here. tangent is negative here and here. Okay, so okay, so we've built it twice. You do have to have it memorized. Please make sure that you get it memorized by Wednesday. There's a blank, if you go to where it says 7-3 unit circle, the thing we did in class together on Friday, there is a PDF version of a blank copy. At this time, take a screenshot of this. Put it in your camera roll on your iPad. It will really be something you're going to use again and again and again for the rest of the school year. So make sure that I would take a screenshot and then have it for yourself so that it's an easy place to locate. So you're not always searching for it, okay? Okay, this little chart is also helpful. So we're gonna fill this out and then we just have a few problems to do and then we're done. I know this lesson is pretty time consuming, but it's just one of the most important things we're gonna do all year long. Okay, so let's just do the chart. Here's another way you can memorize the values. Remember, the sine is your y, the cosine is your x, the tangent is y over x. 0 degrees is 0 radians. This one's pi over 6, pi over 4, pi over 3, and pi over 2. Now let's look at some of the patterns we see here. Your denominator, the largest denominator we have, because 0 is 0 over pi, but the largest denominator we have is 6, and then you'll see how those denominators keep getting smaller. 6, 4, 3, 2, 6, 4, 3, 2. And that's a way that you can see there's a pattern there. So if yours aren't going in some kind of order, you might have done something wrong. This is something cool. I just want to kind of show you how it works. The sine is the y value. At 0, we are at no height. So I'm going to show you a little trick. This is square root of 0 over 2. This is square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. It's just a trick. If we look at the y's, they start at 0, they end in 1. But it's just a little trick. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. It's just a little trick. Now, of course, we wouldn't say square root of 0 over 2. We would call it 0. We wouldn't say square root of 1 over 2. We would call it 1/2. We wouldn't say square root of 4 over 2. We would call it 1. But it is a nice little pattern. So the y's go from 0 to 1. The x's do the exact opposite. They go square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. So whatever the x's are doing, the y's are going to do the opposite direction. Why is that? Well, it's all about complements. The cosine of a complement is the same as the sine of its complement. The cosine of an angle is the same as the sine of its complement. So that's just something neat. Okay, let's do the tangent. This would be y over x. I wrote it sine over cosine on purpose. That's 0 over 1. This is 1/2 over square root of 3 over 2. The 2's cancel. It's 1 over radical 3, which is radical 3 over 3. Square root of 2 over 2 divided by square root of 2 over 2 is 1. This one puts the square root of 3 on the top and the 1 on the bottom. And this is the only one that puts a 0 denominator and is undefined. So your tangents are funky. They come out to be 0, square root of 3 over 3, 1, square root of 3, and undefined. So this little chart just shows you some more of the patterns that we see on the unit circle. So that's just another way for you to see where the patterns fit. So starting at 0, the sine gets bigger until we get to 90. The cosine is biggest at 0, but then gets the smallest at 90. So they go backwards. But they are kind of doing that at the same pace. Okay. So let's use our unit circle for the first time as far as How do we find these things? And I've kind of been mentioning them as we go. But they say to find the exact value of the sine of 4 pi over 3. Now remember, pi over 3 was 60. 4 pi over 3 is 240. So let's think about that as the sine of 240. 240 is right here. All we need is the point. Now that has a reference of 60. So that is the point, negative 1/2, negative square root of 3 over 2. The sine is my y value at that location. Bam, that's the answer, negative square root of 3 over 2. So by knowing the unit circle and knowing that I've landed at the 60 reference in the third quadrant, that 240 is down there, and the point at that location is negative 1/2, negative square root of 3 over 2, I know that the answer is negative square root of 3 over 2. Bam, that's it. That's the answer. Let's do it again. Where does 150 land us? Right here. It has a reference of 30. The point then would be negative square root of 3 over 2, positive 1/2. I found the point. So when they give you, hey, find the tangent of this, find the cosine of this, find the whatever, what's the point? What's the point? What's the point? Where did I land? Where did I land? Where did I land? I landed at the point, negative square root of 3 over 2, 1/2. So it is the y value over the x value. It is the y value over the x value. Now this is what's cool about that. These both cancel. So just cancel them out. And you get 1 over negative square root of 3. Now I'm okay with that. That's an okay answer. We usually do rationalize. So pop the negative in the radical to the top, leave a normal 3 behind. Pop the negative to the top and leave . Okay. Now there's lots of ways to do C. First thing you look at, what's your denominator? 4. Anybody tell me what's pi over 4? How many degrees is pi over 4? How many degrees was pi over 4? Anybody remember? Pi over 2 is 90. So let's cut it in half one more time. What would you get? 45. 45 degrees. Okay. So let's just break down the XY axis into 45-degree chunks. There's 15 of them we got to go. So let's count 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15 of those wedges gets me here. So what is that point? Well, pi over 4 always uses square root of 2 over 2, square root of 2 over 2. In that location, the x is positive and the y is negative. Now, the cosine is the x value, square root of 2 over 2. But they didn't ask for the cosine. They asked for its reciprocal. So once I know the cosine, the secant, just flip it upside down. So put the 2 on top and the radical 2 on the bottom. Now, we don't normally leave it there. That's not customary. Okay. So how do you do it? Well, what's going to happen if you rationalize, you do that by multiplying top and bottom by radical 2. It pops a normal radical 2 to the top. I'm sorry, it pops the radical to the top and leaves a normal 2 behind. The 2's cancel, and you get radical 2. If you have 5 over radical 5, it's going to be an answer of radical 5. If you have 7 over radical 7, it's going to reduce to radical 7. It just kind of always does that. So the flip of square root of 2 over 2 is always going to be square root of 2. If you know that, memorize it. You don't have to do that rationalizing. You can just flip it. Okay, kind of an interesting thing that happens. Now we're running out of time, I believe. So we will continue the last 2 sets of examples tomorrow. But as you can tell, you have a lot to memorize. You got some things to be working on between now and the quiz on Wednesday.